Hi everyone, welcome to Discrete Structure. This is Suki. So before we start our lesson, I want to give you some tips. First, you can control the speed of the videos. You can pause the videos at any time when you need more time to think about the concepts or record the concepts from your previous sessions. You can play the videos again and again, and I strongly recommend you to try the problem first and then continue to play the videos to check your answers. In this way, you can practice more and make sure you understand the concepts and apply the concepts. And when you have questions or confusions on some concepts, please print screen and you can ask me in class, office hours, or send me an email. Alright, so let's start. Chapter 1, Session 1.1 is about sets and logic. So in Session 1, we will define sets and terminology related to sets and notations with sets. This will include how sets are defined, how sets can be written, operations with sets, and other special notation related to sets. So what is set? A set is a collection of objects. The objects in the set are called elements. So a collection of objects, we can have like apple, banana, and orange, right? So this is a set. And the object does not necessarily to be numbers. It can be anything. And the number of objects in the set could be finite or infinite. Okay, so these objects are called elements. Let's look at example 1. Consider the collection of numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So how do we describe it? So D is, we use this brace. So these are called brace. We know this is parentheses and this is brackets and this guy is called braces. Okay, so we use brace to denote sets and we can list all the elements in the sets. So those are the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So by listing all the elements of this set, this method is called the roster method. Okay, another way to express the sets is we can use the sets builder notation where we describe the elements. So what are the properties about those numbers? They are digits, right? So that's why the notation is we put X such that. So this vertical line means such that. Okay, the set D is the X such that X is a digit. So sometimes people use this notation as well. Okay, instead of vertical line. Okay, so they are the same. Alright, so next, what are the relation between elements and sets? Remember the objects in a set are called elements. So the only relation is either that element is in the set or not. So notation, we use small letter a to denote the elements. We use capital letter A to denote the sets. This is what we usually do. So small letter A is the element in the set. Capital A, we use this notation. What does it look like? It's like a C and then you add a horizontal line segment in it, right? This is means belongs to. Okay, so small a belongs to capital A. This is definition, and the meaning is the element small a is in the set A. Example 1 is in the set 1, 2, 3. Right, everybody? Okay, so next. A does not belong to capital A. So does not belong to is we just put a line across the symbol, right? It's like remember this is equal and this is not equal. This is very similar to that. So we have belongs to and does not belong to. Okay? So that means that element A is not in the set capital A. So for example, 4 is not an element of the sets 1, 2, 3. Okay. Let's continue. So standard set. The natural numbers. What are the natural numbers? So usually some textbook use 1, 2, 3, 4. So those are the number you start to count things, right? 1 apple, 2 apples, 3 apples, right? Some textbook also include a 0. It means no apples. Okay, so that this set is called the natural numbers. We also have the integers. So integers is the positive integers 0 and the negative integers, right? Those are the natural numbers union the 0 and all the negative numbers, right? So this is the integer. And you can see both of the sets, we list the elements of the sets. So we're using the Webster method. Next, let's look at the rational numbers. By the way, integer we use z to denote, and for the rational numbers we use q to denote. Okay, so the rational number q is the x such that x equals to p over q, where p and q are integers. So you can see this is a set builder notation. Because there are a lot of rational numbers and it's hard to list all of them, right? So it's better to use set builder notation to describe it. Next, we have the real numbers R. And real numbers is actually consists of the rational numbers and the irrational numbers. So what are the irrational numbers? So such as like square root of 2 and pi and e. So if you use the decimal digits expression, the rational numbers are the decimals repeat, right? For the irrational numbers, the decimals won't repeat. Okay, so rational numbers and irrational numbers, combine them, they form the set of real numbers. And this, we can also have the superscripts. So you can have the R positive to denote positive real numbers. Z negative denotes the negative integers. And I didn't write it here, but the bigger set is complex numbers. Okay, so complex numbers, we use the C. And these are the sets A plus BI, such that A and B are real numbers. Sorry, they are real numbers. And what is I? I is actually square root of -1. Okay, remember square root of a negative number is not defined for real numbers, but square root of negative number is actually a complex number. That's the I. Alright, next. The cardinality of a set is the number of elements in the set. For example, if a set is consists of 1, 2, 3, 4, 5, and then the number of elements is 5 because we have 5 numbers in it. And then next, the empty or the no set denotes this symbol. It's like a 0 and then you cross it, right? So this is the empty set symbol. And you can also use the notation. Remember, we use the brace to denote sets, and you can put nothing in the brace. But I prefer this symbol because sometimes, if your paper is dirty and you have something like this, it looks like you have a 1 in it, right? And it's not empty. So to avoid this confusion, it's better to use this empty set symbol, 0 and cross out. Okay. And what is the number of elements in the empty set? Because it's empty, it has nothing in it, so the number of elements is 0. Okay. So caution. If a set equals, so what is this guy? This guy is not empty. The empty set is the elements of the set. Yeah, remember, a set is a collection of objects, and those objects can be anything. You can have sets of sets, Okay, so actually in this case, the empty set is a set is also an element of the set A. Okay, then in this case, the cardinality of A equals 1, and A is not empty sets because the empty set is an element of this set A. Okay, so so a set can be an element of another set. So a set is a collection of objects. So objects can be anything. Banana, apple, or any set. Okay. Let's continue to look at example 3. Let A be the set consist of 1 and another set 2, 8. What is the cardinality of A? Is 8 an element of the set A? First, what's the cardinality? So the cardinality of A is it 3 or 2? 2. It has 2 elements. 1, the first element is the number 1. The second element is the set 2, 8. Then questions, is the number 8 an element of the set 8? No, 8 is not an element of the set A. So 1 is an element of it, and 2, 8, this set is an element of it. But the number 8 is not an element of A. Okay? Let's continue. So B is the set consists of 3 elements in it, right? Those 3 elements are the set of integers, the set of rational numbers, and the set of real numbers. So the cardinality of B equals 3. So far, so good, everybody? Alright, let's continue. Relation between 2 sets. So here, let's look at each of them. First notation, set A equals set B. So the definition, A equals to B. 2 sets A and B have the same elements, okay? So for example, x such as x squared plus 2x minus 3 equals 0. We can solve this quadratic equation, right? We can try to factor it. Then it's x, and then plus 3 and minus 1 give us plus 2 in the middle, right? And then this guy is 0. It means x equals -3 and x equals 1. So we have 2 numbers, -3 and 1. So these 2 sets are equal. So far, so good, everybody? Next, A is a subset of B. So the notation is this guy. It's really like a C, and then you put a horizontal line segment under it. So this notation means A is a subset of B. What does subset means? It means every element of the set A is also an element of the set B. However, there might be some elements in the set B which is not in A. Okay, so I want to give you some analogy. Analogy would be like 1 is less than equal to 2. Right, you know 1 is less than equal to 2, so 1 is like smaller, 2 is like bigger, right? So here A is a subset of B, so it means A is a smaller set in the set B. Okay, example, let me give you an example here. So we have 1, 2, is a subset of the set 1, 2, 3. Right, everybody? And I also remind you, because subsets, it could be the case that A and B are equal. It's like 1 less than equal to 2, but 2 is also less than equal to 2. Right? So those 2 sets, A and B, could be equal. So subsets, it could be an equal sets as well. Okay, next. A is not a subset of B. Okay, so not a subset, you just cross out that symbol. So it means there is some elements in A, but not in B. Okay, so for example, 1, 4 is not a subset of 1, 2, 3. Because the element 4 is in A but not in B. the analogy, think about 3 is not less than equal to 2, but this is quite, it's a little bit different, because in our number ordering, if 3 is not less than equal to 2, that means 3 is greater than 2. But in this case, A is not a subset of B, doesn't mean that B is a subset of A. So in this case, you don't use this analogy. Okay? So it means there are some elements in A but not in B, but it doesn't mean that B is a subset of A. Okay? They can be like this case, you can see 1, 4 and 1, 2, 3. 1, 4 is not a subset of 1, 2, 3, and 1, 2, 3 is not a subset of 1, 4. Okay. Next, a proper subset. So you can see the difference between not a subset and proper subset is it depends on how the way you cross it. If you cross everything of that symbol, it means it's not a subset. But if you just cross that little line segment, remember that little line segment is really like the equal. So it means that, oh, A is a subset of B, but A is not equal to B, then so A is a proper subset of B. So the analogy for it is like less than, right? 1 is less than 2, okay? So it means all elements in A are also in B, and there are elements in B that are not in A. So for example, 1, 2 is a proper subset of 1, 2, 3. Okay? Next, we have the empty set. The empty set has no elements. We already talked about that. And the empty set is a subset of every set. Okay? So this is a subset of every set. Every set A. Okay, let's continue. We have the union. Union is like OR. So A union B is the set containing all the elements. Those are either in A or in B or both. Okay, this is union. It's like OR. So for example, 1, 2, union 2, 3 equals 1, 2, 3. Okay, you just collect all the elements. But be careful, don't write 1, 2, 2, 3. So elements does not repeat in a set. Okay, you already counted 2 there, then that's it. You don't need to copy it down again. So elements won't repeat in a set. And there is no ordering. So there's no order in the sets. So the set 1, 2, 3 is the same as the set 3, 2, 1. They're the same thing. Okay? Yeah, so let me write it down here. Elements don't repeat in the set. Okay, next we have intersection. So A intersects B. This is a set containing all elements. Those are in both A and B. Okay, so example 1, 2 intersect 2, 3. That equals, so it's like a common element in the both sets. Which elements appear in both of the sets? Well, that's the element 2, right? So for the notation, well, do you think this guy looks like a U? So your U looks like this, right? But you just don't draw it down. So you just draw it like this. Don't draw this guy, okay? Then this is the union symbol. Alright, and this guy, does it look like an N? Yes, then this is the intersection. Intersection means and. Okay, so this is how I remember it. Union looks like U, intersection looks like N. Okay. Next, we have the set minus. So A set minus B is the set of the elements. Those are in A but not in B. So be careful. Let's see. So 1, 2, set minus 2, 3 equals. Okay, so when you do the set minus, you don't have to restrict like the set B has to be a subset of A. No, it is the set A, and then you delete the elements. Those are A and B. So you started with 1, 2, but then you delete the elements. You see, you want to delete the 2, so you delete the 2, and then you delete the 3, but there's no 3 there, so you're good. So that's why what is left is the element 1. Okay, so this is the set minus. You start with the set A, and then you want to delete some elements and then to see what's left. So far, so good, everybody? Okay, so we have both notation. We can use the slash or we can use the minus symbol. Okay, so caution, do not get confused about not a subset and it's a proper subset. So that's why when you do your homework or write your answers, please make sure you draw it nicely, your handwriting. Okay, make sure I can be able to see the difference between not a subset and a proper subset. Okay, so don't draw something like this. This one I can't tell. I would guess you mean a proper subset. Okay, so make sure I'm able to see it, the difference. So either you cross everything or you don't touch the C. Okay. All right, let's continue. The power set. The power set of set A is the set of all subsets of A. Okay, so what other subsets? Okay, let's see. What is the power set of the set 1, 2, 3? So the power set is a set, and the elements of it are the subsets of the set 1, 2, 3. Okay, let's start to count maybe from the less elements to the more elements. So which subset consists minimum number of elements? Well, I would say the empty set, right? Remember, the empty set is a subset of all the sets. Okay, so it has 0 elements. Next, let's look at the subsets with 1 element. So those are 1, 2, and 3. Right? So, and next, let's look at the subset of 2 elements. So those are 1, 2, 2, 3, and 1, 3, right? These are the subsets with 2 elements. How about with 3 elements? Well, that's the set 1, 2, 3. Okay, so this is the power set of the set. Okay, sometimes the notation they use the script F to denote the power set. Oh, does it look like a F? Okay, maybe this is better. Okay, what is the cardinality of this power set? Well, this power set, the cardinality, you can see how many are there. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 of them. So in general, what is the cardinality of a power set of a set with n elements? Well, let me use a different color here. So let's say X is a set with n elements. Let script F be the power set of X. Then what is the cardinality of the script F? Well, the answer is 2 to the n. Okay, why is that? Remember, you have n elements in the set. Well, then each element can choose to appear or not appear in the subsets. So that's why you have n elements. Like say you have n elements. Each element we can have a choice to appear or not. If none of the elements appear in the subset, well, then you get empty sets, right? If one element appear, then you get one element in the subset. So that's why each element we can have 2 choice, either appear in the subset or not. So that's why you get 2 times 2 times 2 times 2. There are n copies of 2 multiplying together. So the number is 2 to the power of n. So far, so good, everybody? Okay, how about I ask you what is the number of proper subsets? Okay, remember the power set is the set of all subsets. Well, then the number of proper subsets is the number of all sets subtract 1, because there's only one is the set itself. This is not proper, and then all the other sets are proper. Okay, that's why the number of proper subsets equals 2 to the n subtract 1. Okay, next, the universal sets. So the universal set, universe, is the set of the sets of all elements under consideration. We usually denote the universal set as U. Okay, it could be all integers, or it could be all real numbers, or it could be a set of finite numbers. Okay, it can be anything. So it's like the universe you want to define. And okay, so next, A bar equals A complement. So the C for the complement is also equals to the universal set minus A. So this is called the complement of A. It is a subset of U that contains all the elements of U. Those are not in A. Let's see. Okay, let me give you a short example. If we let U be 1, 2, 3, 4, 5, and let A be the elements 1, 4, then what is A complement? Well, A complement is inside U but not in A. Okay, so element 1 is in A, so not in A complement. And the number 2 is not in A, so 2 is in the A complement. 3 is not in A, so it's in the A complement. 4 is in A, so not in the A complement. 5 is not in A, so 5 is in the A complement. So this is the complement. Okay? Alright, so let's look at example 4. Consider the following set where U equals 2, 3, 5, 7, 9, 11, 13, 17, 19. And A, B, C, D, E. Okay, so insert the correct symbol. It's a subset, it's not a subset, belongs to or does not belong to, between each pair. Okay, so first of all, when we look at these symbols, well, these two symbols is a subset or is not a subset. They are the relation between sets. Okay, so this is relation between sets. Well, and this is belongs to or does not belong to. This is the relation between elements and sets. Okay, so let's look at the first pair. We have B and E. B and E, they're both sets. So we want to talk about whether it's a subset or it's not a subset. Let's look at the elements. B is the set with elements 2, 3. E is the set 3, 5, 7. Oh, okay. So is B a subset of E? Well, what's your answer? Yes, no, because the number 2 is in B but not in E. So this is not a subset. Okay? Next, 11 and D complement. 11 is a number, so it's an element, right? So we want to fill in whether it's belong to or does not belong to. Okay, so is 11 in the complement of D? Well, let's look at D. Well, D, 11 is not in D, so 11 is in the complement of D, right? So we put belongs to. So far, so good, everybody. Okay, next, C and D. Well, C is 3, 5, 7. D is 2, 3, 5, 7, 9. What do you say? Yes, is a subset. Next, 3 and C complement. Well, 3 is a number, so you want to fill in belongs to or does not belong to. So 3 and C, this is C. 3 is in C. Then 3 is not in C complement. Okay. Next, C and E. Oh, you can see C, all of those elements shows up in E. So C is a subset of E. Okay. And next, 5. What's the relation between 5 and C intersect E? So what's C intersect E? C intersect E is the set of the elements that are in both C and E. Oh, but because C is a subset of E, so actually in this case, this is actually C. But in general, this is not true, okay? But just in this case, C is a subset of E, so their intersection is just C. Well, 5 is in C, so 5 belongs to the intersection. All right, so far so good. Okay, next, let's find the following. First, B intersects C complement. Okay, so let's figure out what it is. B intersects C complement. What is B? B is 2, 3. C complement. Well, C complement means the elements. Those are in U, but not in C. So let's look at the elements. Let's go for the list. 2 is 2 in C? No, then it's in the C complement. So 2 is here. 3 in C. Okay, 5 in C, 7 in C, and then not in the complement. 9 is not in C. So actually all the numbers after 9 are not in C, so they are in the C complement. All right. Intersection means we're looking for the common elements. Those are in both B and C complements. You can see the number 2. 2 is in both of them. So that's why the intersection is the number 2. So far, so good, everybody. This is part A. Part B, D intersects E. All right. What is D? D is 2, 3, 5, 7, 9. Intersect E. So E is 3, 5, 7, 11, 13, 17. Okay, we're still looking for intersections. So which are the common elements? You can see 2 is not common, 3 is common, 5 is common, 7 is common, 9 is not common, and yeah. So the elements of 3, 5, and 7. So far, so good, everybody? Alright, let's continue. So I strongly recommend you to pause here and try the rest, part C and D first, and then you can continue to play the video and check our answer together. Okay? Yeah, that's the good thing about the lecture video. You can pause anytime and you can change the speed. If you think I'm talking too fast, you can change the speed and make it slower, and you can pause to think through the math. Or you think I'm speaking too slowly, then you can double the speed. Yeah, you can increase the speed or slow down the speed. Okay, part C. B complements union D. B complements are the elements that are not in B. So let's go through the list of the U. So 2 is in B, then not in the B complement. 3 is in B, not in the complements. Then you can see all the numbers after 5 are in the B complements. Union D. D is 2, 3, 5, 7, 9. Oh, what happened? Union means you combine all of the elements together. So the smallest is 2, 3, 5, 7, 9, 11, 13, 17, 19. So actually, this is U. Okay, this is U. Do you remember what's B complement? B complement is actually just U delete the 2 and 3. But when you union the D, you see the 2 and 3 was added to that. So that's why you get back the U. Okay, everything. The universal set. All right, let's continue. Oops. Okay, so D. Here, because we have two operations here, we have union and intersections. So, usually, if we don't have parentheses, usually people would do intersection first and then union. Okay, this is usually what people do. But with the parentheses, then we do whatever inside the parentheses first. So the first operation, we do E complement union D. Okay, what is E complement? Well, let's go through the list of U again. 2 is not in E, so 2 is in the E complement. 3 is in it, 5 in it, 7 in it, 9 is not in E, so 9 is in the E complement. 11 in it, 13, 17 in it, 19 is not in it, so 19 is in the complement as well. Union D. D is 2, 3, 5, 7, 9. Well, this is gonna be 2, 3, 5, 7, 9, and 19. Right? This is the union. And then the next steps, we're gonna use the A complement to intersect this new set. So what is A complement? Oh, let's go back up here. Oh, okay. A is number 2. Well, the A complement is going to be everything except 2. So 3, 5, 7, 9, 11, 13, 17, 19. So 3, 5, 7, 9, 11, 13, 17, 19. This is A complement. And we want to intersect the previous sets, which is 2, 3, 5, 7, 9, 19. Intersection means we're looking for the common elements. You see, 2 is common elements, 5 is common, 7 common, 9 common, and then 19 common. So these are 2, 5, 7, 9, and 19. So we have 5 numbers here. So far, so good, everybody? Okay, let me just put down what I said. So here, if no parentheses, then we would do intersection first, then union. Okay, for example, if I do A intersect B union C, then it means we need to do intersection A intersect B first, and then use this answer to union the C. So far, so good, everybody? Okay. Let's continue. Example 5. Consider the following intervals with U equals minus infinity to infinity. A and B and C and D, they are all intervals. All right, let's see. So A intersects B. What is A intersects B? Well, in this case, it's very good to draw pictures. Okay, so let's draw the real number line. And we're looking for the part A. So A, set A, -2 and 4. So -2, do you see brackets? Brackets means we include the endpoints. So we include -2. So you put a solid circle there. Do you see 4 next to the, do you see parentheses next to the 4? It means we exclude the endpoint. So that's why we put an open circle at the point 4. And this is A. All right, so after we draw A, let's draw B. B is 0. Where is 0? Remember, this is the real number line. The negative number is on the left-hand side, and the positive numbers is on the right-hand side. So 0 is between negative 2 and 4. So 0 is like here. 5 is like there. And do you see parentheses around them? So which means we don't include the endpoints. So this is B. And we're looking for intersection. Intersection means the common region. So this is a common region. So that's why we can read from the real number line. We have 0, but do we include the 0? Yes or not? No. So parentheses, and then 4. Do we include the 4? No. So parentheses. So this is part A. So far, so good, everybody? All right, let's look at part C. So let's draw the real number line again. This is our universal set. And then A is negative 2 and 4, right? And do we include negative 2? Yes. Do we include the 4? No. So this is our A. C is negative 3. Where's negative 3? Oh, negative 3 is actually smaller than negative 2, so on the left. And 3 is less than 4 here. Do we include them? Yes, because it's brackets, so we include those points. And this is C. And we do intersection. Intersection is the common area, so common region, right? So we read from the real number line. We have negative 2 and include the endpoints, and 3 we include the endpoints. Okay, so this is interval notation. Let's continue. So C, we have B complement. Oh, so what is B complement? Well, remember, B complements are the numbers that is not in B. Okay, so B is 0 to 5. Think about it. The endpoints 0 and 5. Is 0 in B? So let's plot 0 and 5 there. Is 0 in B? No, 0 is not in B. Then 0 is in the B complement, right? So B complement, B is the numbers between 0 and 5, and then B complements will be the numbers outside of 0 and 5, so which is less than or equal to 0. And do you include 5 in B? No, then 5 is in the B complement, and the numbers greater or equal to 5. This is the B complement. So far, so good, everybody? Okay, next. D. What is D? Well, D is, let me use a different color here. Well, D is minus infinity to 1. Where's 1? Oh, 1 is right here. So we include a 1. So this is D. Okay, and when we do union means under any of them. Okay, so any region under it. So we have minus infinity to 1 brackets because we want to include the endpoints. Union 5 to positive infinity. So when the two interval is not connected, you use the union between them. Okay, so is the interval minus infinity to 1 union the interval from 5 to infinity. All right, let's continue. So part D. Oops. Okay. Okay, so part D, we're gonna have 2 steps, right? So let me change my color back here. So part D, we have 2 steps. First step, we want to compute C complement union D. All right. So what is C complement? Well, C complement is in C. It's not in C, right? So let's draw the real number line. So let's first figure out what is C complements union D. So that is not in C. So not C is -3 to 3, not in C, so which is outside of it. So, and because C include the endpoints, then the C complements will exclude the endpoints. Okay, so this is C complements. And D, what is D? Well, D is -infinity to 1. So let me change a different color here. So 1 is, oops, E. Let me see. Okay. My work is slow. Okay, so this is 1. Okay, so this is the D. Okay, and we're looking for union. Union is everything under any of them, right? So the union is going to be -infinity to 1 and include the endpoints. Union 3 to infinity. Okay, so next we want to use the A complement to intersect them. So let's use A complement. What is A complement? Well, A complements, so A is -2 and 4. So A complements, because -2 is in A, then it's not in the A complement. 4 is not in A, then 4 is in the A complement. So this is the A complement. And we wanted to intersect what we had before. So what we had before, let's change back to this color. So we have 1 included. And we have 3. So 3 is right here. So excluded. So, okay, we are looking for intersection. Intersection means the common area, which is these P's and this P's. Okay, so what do we get? Well, I almost ran out of space. So this is -infinity to -2 excluded, union 4 included, so brackets to infinity. Alright, so this is our answer. So far, so good, everybody? Okay. Next, I want to show you the Venn diagram. Okay, so what is the Venn diagram? First, Venn diagram is some geometry. Figures can help us to understand the relationship between the sets. So first, A is a subset of B. Well, A is a subset of B, then we can have B to be the bigger set, A to be the smaller set. So now you can see the set A is contained entirely in B. Then A is a subset of B. Okay, so this is the Venn diagram. How about A union B? Well, let's draw the rectangle. So the rectangle represents the universal set U. Okay, so A union B. So we have two sets. We usually use circle or ellipse to denote the sets. Usually, so union means is you consider any numbers in either in A or in B or both. Okay, how about intersection? Well, intersection, let's still draw. Let me make this bigger. Okay, so let's draw the two sets A and B. Okay, A intersects B, which means the common elements, right? The elements that are in both A and in B, right? Okay, how about A set minus B? Well, A set minus B, it means the elements that are in A but not in B. Okay, so A set minus B is the same thing as, remember, elements in A but not in B. Not in B means in the B complement. So this is another notation of set A set minus B is in A, right? So A intersects, not in B, so then it's in the B complement. Okay, so next, A complement. Well, we have the universal set, we have the set A, and then A complement will be everything outside of A, right? So this is the A complement. I draw it in A, so let me draw it better. Okay. So this is the A complements, and U is the universal set. So this is the Venn diagram. So far, so good, everybody. Okay, next, let's look at example 6. And I'm going to show you how to use the Venn diagram to solve this problem. Have you ever played a logic puzzle? So this is actually one example of a logic puzzle. Very interesting. Okay, so among a group of 165 students, 8 are taking calculus, psychology, and computer science. 33 are taking calculus and computer science. 20 are taking calculus and psychology. 24 are taking psychology and computer science. 79 are taking calculus. 83 are taking psychology. 63 are taking computer science. So how many students are taking none of these 3 courses? How many students are taking calculus or psychology? Okay, let's draw the big picture. Okay, so let me draw a big picture here. So we're going to have 3 subjects: calculus, psychology, and computer science. So let's draw it here. So we have 3 subjects of 3 circles. Let's use this one is the calculus. This is the psychology. And this is the computer science. Okay. So the total is 165 students. So 8 are taking calculus, psychology, and computer science. So this number 8 means we have 8 students taking all 3 of them. So which means number 8 is in the middle. Remember this region is in the calculus, in the psychology, and in the CS. So that's why we have this the intersection. This is the intersection of all 3 of them to be 8. Okay, so this is number 8. We have 8 students there. 33 are taking calculus and computer science. Okay, so what is that? Well, calculus and computer science. So calculus and computer science, the intersection is right here. Okay, it's right here, and we have 33 students there. Okay, so this common region is 33. Then how about this guy? Well, because this total piece is 33, then this piece is 33 minus 8. Okay, so here is 33 minus 8, which is 25. So this is 25. Okay, so this region is taking calculus and computer science, but not psychology. Okay. Next, we have 20 are taking calculus and psychology. So 20 calculus and psychology is here. So it covered 2 regions. Okay, so that's why we know, because this region is 8. Then what is this region? Well, then this region is gonna be 20 minus 8, which is 12. Okay, so this region denotes the students that are taking psychology, calculus, but not computer science. Okay, next, 24 are taking psychology and computer science. So psychology and computer science is these 2 regions. This 2 region, but we know the middle region is 8. Then how do we find out this region? All right, so this region is 24 minus 8. Well, 24 minus 8, that is 16, right? So we know 16 students that are taking psychology and computer science, but not calculus. Okay, let's continue. Let me use a different pencil. Pen. Okay. All right, next. 79 are taking calculus. So which means the whole thing here taking calculus is 79. But we already know 3 region, the 12, 8, and 25. What is the remaining region? Well, the remaining region is going to be 79. Subtract all 3 of them. Right? So that is 79 minus 12 minus 8 minus 25. Okay, so you know 12 and 8 is 20, 20 plus 25, 45. 79 minus 45 is 34. So we have 34 students here. So far, so good, everybody. All right, next. We have 83 are taking psychology. So 83 are taking psychology. Psychology is right here. So we have 83, but psychology is everything is psychology. Okay, everything in this circle is psychology. So we want to figure out this region. Well, this region is then 83 minus the other 2 region, 12, 8, and 16. Well, 12 and 8 is 20. 20 plus 16, 36. 83 minus 36 is, let's see. Is it 47? Okay, that's 47. Okay, next. 63 are taking computer science. So everything here is 63. Then this region is 63 minus the other 3 region, 25, 8, and 16. So what is that? Oh, okay. So let's see. You know, 8 plus 16 is 24. 24 plus 25 is 49. 63 minus 49 is it 14? Yep. All right. So now we have figured out a lot of region. Okay, finally. We still have one region that we haven't figured out. What is it? Well, that is the region outside of those 3 circles. So it represents the student taking none of the 3 courses. Okay, so it's gonna be remember the total number of students is 165. So we use 165 to subtract all the numbers like show up in those region. We already find it. Okay, so but we remember this guy. This guy is the calculus students. So how many calculus students? We have 79 calculus students. And then you subtract the 47 and 16 and 14, right? So 47, 16, and 14. So these guys will save us a little work. Because otherwise you're going to subtract 34, subtract 12, subtract 8, subtract 25. So more number to work with. Okay. So let's see. I think in a lot of number here. So I'm going to use my calculator. So 165 subtract 79, subtract 47, subtract 16, subtract 14 equals 9. Okay, so this answer is 9. Okay, so let's try to answer the problems. How many students are taking none of these 3 courses? Well, that is 9. We already figured that out, right? Next, how many are taking calculus or psychology? Okay, what does that mean? Calculus or psychology. Remember, or is union, Okay, so calculus or psychology, so which means is like this peanut shaped thing, right? This peanut shaped thing is, well, we have the calculus, right? We calculus the plus 47 and plus 16. Well, what is the calculus? Well, the calculus is 79 plus 47 plus 16. And let me see, 79 plus 47 plus 16. My answer is 142. Okay, so that is this blue peanut shaped area. Okay, this guy is 142. So this helps us to solve the problem. So actually you can see after we draw the information and draw the Venn diagram and figure out the number of each region, then no matter what the answer is, we can always answer it. Just figure out the correct region and add those numbers. Okay, so far so good, everybody. Okay, so let's take a little break here. We will continue in video part B. See you soon. Bye.